Hello everyone, my name is Sucheth Shenoy and I'm proud to present to you Team Topspin Trackers for the OpenCV AI Competition 2021. The team is led by Kaustubh Kulkarni and consists of Rohan Jamadagni, Jeffrey Paul and me. We are a group of undergraduate students from Bangalore, India. We have developed a sports analytics system for table tennis using strategically placed OTs such that they record video data pertaining to all the key aspects of the sport while being sparingly intrusive and compliant to the rules of the sport to the best of our knowledge. This is the player side of the table where the video recording for analysis takes place. We have used a total of 3 OGDs in our system, out of which 2 are mounted on the net clamps. These 2 OGDs record and analyze the strokes executed by the player. We have developed custom designed frames which house a Raspberry Pi Model 4 to interface to OAK-D. The Raspberry Pis are connected to a router via Ethernet. A vibration sensor is mounted underneath the table at the center of each side and it is connected to the RPi. These two sensors sense the vibrations produced when the ball pitches on the corresponding side of the table. The third OAK-D is placed at the umpire's view of the table. This OAK-D tracks the ball efficiently and enables us to draw further inferences from the gathered data. This concludes an overview of the hardware setup involved in our table tennis analytics system. Here, we begin a session by clicking the Start Record button. For the first time, the coordinates of the table have to be selected for accurate perspective transformation. This will initialize all 3 cameras simultaneously. The player will now start the practice session. Now the player on the recording side is executing 4,000 strokes. The number of strokes played in this rally is 9. Now we can see the videos recorded by OAK-D1 and OAK-D2, followed by the post-estimation output from the OAK-D on the splits generated using vibration sensor data. This is the view from the third OAK-D placed at the umpire's view of the table. Once the practice session is complete, the player will click the Stop Recording and Analyze button. This will stop the recording on all the OAK-Ds and initiate the post-processing pipeline. Once the post-processing is complete, the player can view the session's statistics by clicking on the player reports. As we can see, there is a stroke frequency table that tells us the count of each stroke in the rally and a rally replay table that gives statistics like the zone in which the ball has pitched and the speed of the ball. The player can also visualize the session by clicking on Visualize. On the top, we can see the zone heat map, and at the bottom, we can see the trajectory of the ball in each stroke. With further fine tuning of the UI, we can filter out statistics and visualization based on the various strokes played in the session. Next, the player is playing a free-flowing rally with a sequence of different strokes as labeled on screen. These kinds of rallies are often observed in matches played at competitive table tennis tournaments. The statistics generated by our system for the rally played is as shown, illustrating the strokes executed, their frequency of occurrence in the rally, their speeds, and the placement zones. The statistics and visualizations developed by our system can help both intermediate and professional table tennis players improve their performance levels. Coaches can use the players' data generated during both training as well as match scenarios to pinpoint the weaknesses and scope for improvement for their players. Finally, the team would like to thank OpenCV for conducting this competition, providing us with the workdays to carry out this project work, and for graciously extending the submission deadlines in view of the pandemic situations. Thank you.